In this video, we're going to begin to take a look at how we can divide fractions. To set this up, we're going to look at the example 2/3 divided by 5/7 in detail. Well, remember that this division symbol really can be represented in another way, as a fraction bar. So another way I could write this division problem is I could write 2/3 divided by, as a fraction bar, 5/7. Now this looks really weird because we've got fractions inside of a fraction. So we're going to try and make it into a nicer form. The nicer form would be to have no fraction down here in the bottom. In fact, if we had 1 in the denominator, it would be the same as just having the numerator. Just like 5 over 1 is the same as 5, 2/3 over 1 would be the same as 2/3, or whatever we end up with. So if we could get rid of this denominator by making it 1, it would be a lot nicer. How can we do that? Well, we'll multiply this fraction by something that makes this fraction in the denominator equal to 1. What we found out recently is that when we multiply by reciprocals, the answer is always 1. So if we multiply by 7/5, the reciprocal of 5/7, that'll make the answer 1 in the denominator. However, if we multiply by 7/5 on the bottom, to keep the equal value, we're going to multiply by 7/5 in the numerator. What's nice is the 5s and 7s divide out with each other, and what's left is actually just this multiplication problem. 2/3 times 7/5 multiplying across gives us 14/15. But what I want to notice that we did here is we didn't actually do any division at all. Instead, we multiplied by the reciprocal of the second fraction. This is what we're going to do as we divide fractions. We'll identify that second fraction, and to divide fractions, we will multiply by the reciprocal. So let's look at some examples where we divide fractions by multiplying by the reciprocal. In this example, we have 3/2 divided by 7/9. We're never going to divide with fractions, so we're going to take the reciprocal of that second fraction. The first fraction always stays the same, multiplying by the reciprocal 9/7. There's no reducing, so we'll multiply straight across. 3 times 9 is 27 on the numerator. The denominator's 2 times 7 is 14. And we get our final product of 27/14. Let's try another example where we divide by actually multiplying by the reciprocal. In this problem, we have 4/9 divided by 6/15. Again, with division, we're going to multiply by the reciprocal of that second fraction. 4/9 times 15/6. This time, we can do some reducing. Remember, with multiplication and multiplication only, we're allowed to reduce. 4 and 9 are divisible by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. 9 and 15, they're both divisible by 3. 9 divided by 3 is 3, and 15 divided by 3 is 5. And now that we've reduced everything, we can multiply the numerators and denominators together. 2 times 5 is 10, over 3 times 3 is 9, and we have our final quotient, or product, because we multiplied by the reciprocal, of 10/9. Division is exactly the same as multiplication, with one extra step at the beginning, where we multiply by the reciprocal.